JAXA, this is Mission Control. Houston, please call the station for a voice check.
Station, this is JAXA PAO. How do you hear me?
I read you loud and clear. よく聞こえます。
柳田さん OK です。
急いでいるんですけれども、音声の確認を進めておりますので、
柳田さんスタートしていいですよ。
ください。準備ができ次第またおつなぎいたします。
はい、よく聞こえております。
すみません。もう始めるそうな気配はあるんだけど。I can hear you well. そうなんだ。そう。
東京の皆様、こちらはよく聞こえております。音声いかがでしょうか。
Everyone in Tokyo, I can hear you well. How do you hear me?
聞こえた、聞こえた。
皆さん、こちらはよく聞こえております。そちらいかがですか。
I can hear you well. How do you hear me?
もうSE？
こちらよく聞こえております。
I can hear you well.
はい、皆様大変お待たせいたしました。
Thank you for waiting.
ISS 古川宇宙飛行士
We've got connected with Furukawa-san on the International Space Station. I'd like to call him. Furukawa-san.
皆さんこんにちは。国際宇宙ステーション ISS から JAXA の
Hello everyone. I'm Satoshi Furukawa, JAXA Astronaut. I'm speaking to you from the International Space Station. Thank you, Dr. Furukawa.
今、古川宇宙飛行士は ISS の
Furukawa-san is currently
お話ししてくださっているんですが、
speaking to us from the ISS Kibo module.
宇宙飛行士の今、気象上の映像をお届けしているという
We are now
斬新な機会になっておりまして、
showing his footage on the Zoom.
ハートですとか笑顔の
We've got many smiles and hearts
おります。
popping up on the screen.
最近の ISS のお仕事ですとか生活の様子、
How are you doing
教えてください。
these days on the ISS?
はい。
Your work and your life on the ISS.
長く続く微小重力という地上では得られない宇宙環境の特殊性を使って
I have been living in the microgravity for many days.
近い将来の有人探査に向けた技術実証とか進めています。
Doing a research to improve the life on the Earth and also conducting technological demonstrations for future human explorations. I'm also doing a research on the protein crystals and also conducting technological demonstration of water recovery systems. So, considering future human exploration, you have been conducting many experiments. The participants attended the series of lectures before this. So, we like to check whether the participants understood today's webinar well. So, Furukawa-san will ask questions and also explain the reason. And we also accept the questions for Furukawa-san live. So if participants have any questions for him, please let us know. Before starting the quizzes, many people are participating in this event, and please give us a like reaction if you're excited today and if you're determined to answer all the questions correctly. Yes, we've got many reactions. So Furukawa-san, would you please ask us the first question?
月極域の水資源の探査を目的とした JAXA で進行中のプロジェクトはどれでしょう？ A.
Which of the following is an ongoing JAXA project aimed at exploring water resources in the lunar polar regions? A. SLIM, B. LUPEC, C. MMX.
皆さん回答は10秒で
Okay, everyone, please vote on the Zoom in 10 seconds.
目的とした JAXA で進行中のプロジェクト
What is the ongoing JAXA project aimed at exploring water resources in the lunar polar regions? SLIM, LUPEC, MMX. So let's see how the answers are coming in. A, SLIM, got the most answers. And the next is the LUPEX and followed by MMX. So, Furukawa-san, what is the correct answer? And tell us why it is so.
はい、正解は B の月極域探査ミッション LUPEX です。
The answer is B. LUPEX, Lunar Polar Exploration Mission. Water is precious in space, and on Kibo, we are working on water recycling using a water recovery system. Water is not only for drinking, but by extracting hydrogen from water, we can use it as a fuel, and it can be valuable resources for future explorations. The LUPEX project aims at investigating the volume and quality of water on the moon. Thank you. So the answer is B, LUPEX, Lunar Polar Exploration Mission. Sorry for those who chose A. So the first question was about the International Space Exploration. So this is a kind of a technical demonstration that you didn't conduct in your previous expedition. Yes, that's right. The recycling system to convert urine into drinking water was conducted in the 2011 expedition. Compared to the previous expedition, we are working more on how to make use of this International Space Station for future human exploration. Thank you very much for telling us the answer. Now, the second question is about robotics. Have you worked with INTBall 2? How is it making progress?
はい、つい先日もイントボール2の動作確認に立ち会いました。
Yes, I checked the movement of INTBall the other day. On the International Space Station, wind is always blowing for ventilation, so it's very difficult to keep it still without being swept away by the wind. But when it moved to our commands and came to rest, we all of us cheered. Yes, so robots are already supporting the crew. Now, Furukawa-san, give us the second question.
はい、第2問。ロボティクスにおける技術的障壁のうち
Question number 2. What are technological challenges for introducing robotic technologies, especially beyond the low Earth orbit? A. Dealing with communication delays caused by long distance. B. Dealing with complex interfaces due to human-oriented environment design. C. Dealing with dynamic environments where ambient conditions such as the position of the objects and light change. Okay, everyone, please vote in 10 seconds. The second question is about robotics. C got the most answers. Dealing with the dynamic environments where ambient conditions, the position of objects and light change. The C got the most answers, followed by A and B got this number of answers. Furukawa-san, please tell us the correct answer. This might be a very tough question. For interval 2, generally speaking, the answer is A, dealing with communication delays caused by long distance. The ISS is flying 400 kilometers above the Earth, and the communication is via stationary satellites, so the round trip is 150,000 kilometers, meaning that there is a delay of seconds. In case of Mars is 20 minutes away at the light speed, so a round trip takes 40 minutes. So, therefore, we need to improve remote control technology, automation, and autonomous technology. A. So the correct answer is A, dealing with communication delays caused by long distance. This must have been a very tough question. So those who answered A, congratulations. Okay, let's go to the next question. Next question is about improving fire safety in space. Furukawa-san, are there any fire safety precautions you take in space?
外部が真空の国際宇宙ステーションでは万が一火事が起こると外部に逃げられないのでとても大変です。
The outside is vacuum, so if a fire breaks out, we cannot escape to the outside. Maybe you have heard in this today's seminar, all equipment is designed to prevent fires on the ISS, but just in case, each module is equipped with a fire extinguisher. So I was also trained on how to use fire extinguisher. Okay, so give us a question.
はい、第3問。皆さんご存知だと思いますが、地上でろうそくを燃やすと
Question number 3. As you may know, when you burn a candle on the Earth, the hottest part of the flame is not inside the flame, but where the flame is in contact with the outside air. Then, what is the hottest part of the flame when burning a solid material in a microgravity environment?
B.
A, near the boundary between the flame and the surrounding air. B, inside the flame. C, the temperature is the same everywhere. So please give your answer in 10 seconds. What is the hottest part of the flame when burning a solid material in microgravity environment? Near the boundary, inside the flame, or the temperature is the same everywhere? Now 10 seconds have passed. A got the most largest number of answers, followed by B. So what is the correct answer, Furukawa-san?
正解は A、火炎と周囲空気の境界付近です。
The answer is A, near the boundary between the flame and the surrounding air. When vapor from fuel burns with oxygen, a flame surface is formed at a point where complete combustion of the fuel occurs. This does not depend on the presence or absence of gravity, so the hottest part of the flame will be the outer side of the flame in space as well as on the Earth. Thank you, Furukawa-san. So the correct answer is A. So the last question. The last question is about the communication between the Earth and the International Space Station. Question number 4. Which of the following frequency bands will be used mainly for ISS emergency voice communication? A, S-band. B, KU band. C, KA band.
皆さん考えてみてください。10秒です。さあ、ISS の緊急時の音声更新で周波数帯域どれをメインに使っているのか、
What is the frequency band used for emergency voice communications between the ISS and the Earth. 10 seconds have passed. B got the most answers, followed by A and C. The answers were split among the three choices. So, Furukawa-san, what is the correct answer?
はい、難しかったかもしれませんが、正解は A、S バンドです。電波というのは
This must have been a tough question. The answer is A, S-band. Radio waves are more susceptible to attenuation at higher frequencies. Ku and Ka bands are attenuated by rain and clouds in the atmosphere of the Earth. So, in case of emergency communications, we mainly use the lower frequency, S-band, to establish more reliable communication. Thank you. So the answer was A, S-band. So 4 questions were asked. Would you please give us a reaction if you answered all the questions correctly? Well, there's many, but we also see some sad faces popping up on the screen. So now we'd like to move on to a Q&A session. First, we pick up questions we received in advance. Compared to your previous expedition, what has changed or not changed on the ISS?
はい、変わった部分は、内部の電子機器を中心に、あと実験装置とかがより新しく、優れたものに変わっている。
Electronic devices or experiment devices, they became updated, became much more sophisticated, and the new modules by private companies have been added. So, using new equipment, we can enjoy more faster communications, and we can conduct the state-of-the-art experiments. And some additional parts were made by private companies. So I can feel that the preparation is underway for commercial flight. But the main body and the teamwork between the crew and the mission control on the ground, such communication and teamwork remains unchanged. The style of work remains unchanged. And work procedure has changed from paper to iPad. What is the difference between the muscle you use on the Earth and also on the International Space Station? It seems like to stabilize your body posture only with your feet must require a lot of muscle strength. Thank you for your question. The muscle, the way I use muscle is different from the Earth. On the Earth, we use our foot to sustain the posture, but on the Earth, I have to fix my body. When I move on the ISS, I have to use my body in a different way, but I easily lose my muscle strength in space, so I have to train myself to maintain my muscle strength, so that I can keep my muscle strength as I'm living on the Earth. And would you please give a message to those who are participating in this event in about 20 seconds? Please continue to ask questions and use your head. When you think about anything, Dr. Furukawa, so we wish you good luck. Thank you everyone for taking part in this event.
Station, this is Houston ACR. That
All right.
concludes the event.
Thank you to all the participants from JAXA. For the ISS, we will now be resuming operational space to ground.